Hello students. So today we will go to exercise 1.6 where we will be dealing with some problems. Let us start with the first question which says x and y are two sets. Number of elements in the set x is 17. Number of elements in the set y is 23 and number of elements in x intersection y is 38. You have to find number of elements in, this is union y. You have to find number of elements in x intersection y. So the formula we will use is n of x union y equal to n of x plus n of y minus n of x intersection y. So n of x union y is 38. N of x is 17, n of y is 23, and n of x intersection y we have to find. So we can write 38 equal to 40 minus n of x intersection y. Or n of x intersection y is equal to 40 minus 38, which is 2. That is what they have asked. Let's go to second question. In second question, x and y are two sets. N of x union y, number of elements in x union y is 18. Number of elements in x is 8. Number of elements in y is 15. And we have to find number of elements in x intersection y. So it is same as the previous one. N of x union y equal to n of x plus n of y minus n of x intersection y. So we know n of x union y is 18, n of x is 8, n of y is 15, and we have to find n of x intersection y. So 18 equal to 23 minus n of x intersection y. N of x intersection y is 23 minus 18, that is 5. Let's go to third question. In a group of 400 people, so I will draw the set. Total 400 people. There is a set H. That means people who speak Hindi. That is the set. So number of people who speak Hindi is 250. There is another set E. That means people who speak English. So number of people who speak English is given as 200. And they're asking how many people can speak both Hindi and English. That you have to find. So we can say N of H union E, total people 400. You can use the same formula. That is N of H union E equal to N of H plus N of E minus N of H intersection E. N of H union E is 400. N of H is 250, N of E is 200, and we don't know what is N of H intersection E. So N of H intersection E will be 450 minus 400, that is 50 will be the answer. Coming to question number 4. Again, I will draw universal set. In this, S and T are two sets. This is S. This is T. Number of elements in S is 21. Number of elements in T is 32. Number of elements in S intersection T is 11. You have to find number of elements in S union T. So the formula for N of S union T is N of S plus N of T minus N of S intersection T. N of S is 21, N of T is 32, and N of S intersection T is 11. So we have 53 minus 11, that is 42. Let's go to question number 5. X and Y are two sets. Number of elements in the set X is 40. Number of elements in X union Y is 60. Number of elements in X intersection Y is 10. You have to find number of elements in the set Y. So N of X union Y is N of X plus N of Y minus N of X intersection Y. N of X union Y is 60. N of X is 40. N of Y we don't know. N of X intersection Y is 10. So I can say 60 minus 30 will be N of X. Sorry, N of Y. This should be Y. So number of elements in the set Y is 30. Okay. Next, we will go to question number 6. Here we have universal set in a group of 65 people. So total we are taking 65 people. Actually, by mistake, I have taken 7th question. So let me erase this. Question number 6. In a group of 70 people, so total 70 people are there. I am drawing a circle C. C means people who like coffee. So number of elements in the set C is 37. I'll take another set T. T means people who like tea. So number of elements in T, it's given as 52. Each person likes at least one of the two. That means they don't have any option. They have to like either tea or coffee or both. They can't be left alone. That means total number of people, C union T, comes out to be 70. We have to find how many people like coffee and tea. C intersection T we have to find. So you can use the formula N of C union T equal to N of C plus N of T minus N of C intersection T. N of C union T is 70, N of C is 37, N of T is 52, and N of C intersection T we don't know. So N of C intersection T will be 90. No, not 90. When you add 37 and 52, what we will get? 89 minus 70. That is 19 people like coffee and tea. Like coffee as well as tea. Let's go to 7th question. Here again, I will take universal set. In a group of 65 people, I will draw a set C. C means people who like cricket. And I will make another set T. T means people who like tennis. So N of C who like cricket is 40 and N of C intersection T who like cricket and tennis both. Such people are 10. So you have to find how many people like tennis. And then how many people like tennis only. Tennis only. And next, tennis only means I can write like, okay, I will tell you about this later. At present, I am writing tennis only. So these two you have to find. Tennis only means they like tennis but not cricket. N of T minus C. Remember that. So this area is C minus T. This area is C intersection T. And this area is T minus C. So first of all, I will take N of C union T equal to N of C plus N of T minus N of C intersection T. N of C union T, total we have 65. N of C is 40. N of T we don't know, we have to find. And N of C intersection T is 10. So 65 minus 30 equal to N of T. So people who like tennis, you can take it as 35. 35 people like tennis. Okay. Now they are asking number of people who like tennis but not cricket. That means you have to take N of T. From that, you have to subtract N of C intersection T from the diagram. So from 35, you have to subtract 10. So 35 people, 25 people. So 35 people minus 10 people, we are getting 25 people. 25 people like only tennis, not cricket. Next, we will go to question number 8. I will draw a universal set. In a committee, we don't know how many people are there, but I am drawing a circle F. F means those who speak French. Then I will draw another circle S. S means those who speak Spanish. So it's given number of people who speak French is 50. Number of people who speak Spanish is 20. Number of people who speak Spanish and French. So this is who speak Spanish and French, both. So 10 people are there who speak Spanish and French. How many speak at least one of the two languages? At least one of the two languages means S union F. At least one of the two languages we have to find. At least one means at least Spanish or at least French or both. That is why it is union. So in order to find n of S union F, you have to take n of S plus n of F minus n of S intersection F. N of S is 20, n of F is 50, n of S intersection F is 10. So 70 minus 10, 60 people speak at least one of the two languages. So total 8 questions are there and we have done all the 8 questions. Now, after this, after exercise 1.6, we have some miscellaneous examples. So we will do these miscellaneous examples. I think some 4 or 5 questions are there. We can complete in this class itself. Let us take the first one. Show that the set of letters needed to spell cataract. Show that set of letters needed to spell cataract and the set of letters needed to spell tract are equal. So I will first list the set A in which we need letters to spell cataract. C, A, T, I need not write A. R, again A I need not repeat. C I need not repeat. T I need not repeat. So these. I will write the set B in which the letters are taken from tract. I'll write T, R, A, C. That's it. I will not repeat T. So you can see T is present in both, R is present in both, A is present in both, C is present in both. That means I can say set A is equal to set B. Okay, next. Second question. List all subsets of the set -1, 0, 1. So when I want to list it, first I will take empty set. Then I will take only -1, only 0, only 1. Now I will take two numbers. That is -1, 0, -1, 1. Any other one? 0 and 1 also I can take. Next I will take all the 3 numbers. So if I name this set as A, n of A is 3. And if I take this as power set of A, all the subsets, so what is the number of elements in the power set? 1, 2, 3, 4, 5, 6, 7, 8. It's 2 cube and it is 8. So we did not forget anything. We have written all. Third one. Show that A union B is equal to A intersection B implies A is equal to B. How will you show? First of all, we will take an element A in A. That means A will definitely be there in A union B. Now, because A union B and A intersection B are same, that implies A will be there in A intersection B. That means A is there in A and A is there in B. That means we are starting with A is in A and we got A is in B. That too. So we can say all the elements, it will happen that. For all the elements in A will be there in B. For all elements. That means we can say set A will be equal to set B. Fourth question. Show that power set of A intersection B is power set of A intersection power set of B. Now suppose I will take power set of A intersection B, in which there is a set X. X belongs to power set of A intersection B. That means what I can say X is subset of A intersection B. That means X is subset of A and X is subset of B also. That means the set X belongs to power set of A and the set X belongs to power set of B. So it happens for all sets which belong to power set of A intersection B. What we get is X belongs to power set of A and power set of B. That means these two sets are equal. Power set of A intersection B is equal to power set of A intersection power set of B. This is how we can prove it. Now we will go to question number 5. A market research group conducted a survey of 1,000 customers. So in the universal set, total we have 1,000 customers, and reported that 720 customers like product A. So circle A means liking product A. So how many customers like product A? 720. There is another circle B. That means customers who like product B. So how many customers like product B? 400 consumers. What is the least number that must have liked both the products? A intersection B. That means liking both products. That is what we have to find. So N of A union B is N of A plus N of B minus N of A intersection B. N of A union B means total. It is nothing but universal set. So 1000. N of A is 720. N of B is 450. And N of A intersection B, we don't know. So I can write 1000 equal to 1170 minus N of A intersection B. Or n of A intersection B is 1170 minus 1000, that is 170. It's very simple. Next, we will go to question number 6. For this also, I will draw universal set. It will be easy to understand. Out of 500 car owners, total 500 car owners, A means car A owning car A. So number of persons owning car A is 400. Next, a set B, that means persons owning car B. Number of persons owning car B is 200. Now, number of persons owned both the cars A and B. Those who are owning both cars, that you have to find. So you can take n of A union B is equal to n of A plus n of B minus n of A intersection B. N of A union B will be universal set only. So 500. N of A is 400. N of B is 200. And n of A intersection B, we don't know. So n of A intersection B will be 600 minus 500, that is 100. Let's go to question number 7. For this also, I will draw Venn diagram, universal set. A college awarded 38 medals in football. So F means number of medals in football. So number of medals in football, 38. Now I will make another set B. B means medals in basketball. So number of medals in basketball, 15. There is one more circle, C. That means medals in cricket. So number of medals in cricket, 20. So there are 3 sports. Only 3 men got medals in all the 3 sports. All the 3, F intersection B intersection C. Medals in all the 3 sports. So only 3 men got medals in all the 3 sports. So how many medals are received in exactly 2 of the 3 sports? So 2 sports, either football and basketball, number of medals in basketball and cricket, or number of medals in football and cricket. That means we are finding medals in exactly 2 of the any 2 of the 3 sports. This is what we have to find. So what I will do here is I will write here 38, I will write here 15, and I will write here 20, and in the center I will write 3, because all the 3. And now total we have to take N of F union B union C. That is given in the question. If these medals went to total 58 men, total men who received medals is given as 58. This is also given in the question. So based on that, we will take the formula N of F union B union C is N of F plus N of B plus N of C minus N of F intersection B minus N of B intersection C minus N of F intersection C plus N of F intersection B intersection C. So N of F union B union C, I will write 58. N of F 38. N of B 15. N of C 20. I will take minus common from N of F intersection B, N of B intersection C, and N of F intersection C. Whereas N of F intersection B intersection is B intersection C is 3. So I have 58 is equal to 38 plus 15, 53 plus 20, 73 plus 3, 76. Then minus, in brackets I have N of F intersection B plus N of B intersection C plus N of F intersection C. So from this, N of F intersection B plus N of B intersection C plus N of F intersection C will be 76 minus 58. And that is 18 people. So the answer will be 18. So with this, we have completed miscellaneous examples. Now we will go to miscellaneous exercise. In miscellaneous exercise, total 16 questions are there. We will try to complete as many as possible. If we are not able to complete now, we can do this in the next class also. We have option for next class. Okay, first question. Which sets are subsets of one and another? A is having x such that x belongs to set of real numbers and x satisfy x square minus 8x. X square minus 8x plus 12 equal to 0. That means when you factorize x minus 6, x minus 2. So in this set, we have 2 elements. Then the set B is having 2, 4, 6. The set C is having 2, 4, 6, 8. And the set D is having just 6. Looking at it, we can say that which are the subsets of one another, they said. So if you list out, I'll change the color of the pen. About A, what you can say, A is subset of B. A is subset of C. A is not subset of D. A is not subset of D. About B, what can you say? B is not subset of A. B is subset of C. B is not subset of D. About C, what you can say? C is not subset of A. C is not subset of B. C is not subset of D either. About D, D is the subset of A. D is the subset of B. D is the subset of C. So finally, we can combine and also say D is subset of A. A in turn is subset of B. B in turn is subset of C. In either ways, we can write. Let's go to question number 2. Here you have to say true or false. First, if X belongs to A and the set A belongs to set B, then X belongs to B. You have to say whether it is true or false. Why? How will you say? Suppose if I say A 1, 2, and because A belongs to B, B I have to take something like 1, 2, and 3, because 1, 2 should be element of B. Then you can say A belongs to B. Okay. Now, suppose I will take 2 belongs to A. And we also know that A belongs to B. But 2 does not belong to B. So what they gave is false. Let's go to the second one. If A is subset of B and B belongs to C, then A belongs to C. This is what we have to prove. I will say this is also false. How? I will take A as 2. Now, because A is subset of B, B I have to take in such a way that 2 should be there in B. Like this. And now, because B belongs to C, when I write C, this 0, 2 must be one element in C. Apart from that, if I want, I will take 1, 3 like this. We know that A is subset of B. We have taken like that. We know B belongs to C. That also we know. But A is not an element. We don't have 2 belonging to C as an element. So this is false. Okay, third. If A is subset of B and B is subset of C, then A is subset of C. So I will say that this will be true. I know that. So according to the question, A is subset of B. That means if X belongs to A, then X belongs to B. Next, B is subset of C. That means already we know X belongs to B. As X belongs to B, We can say that X belongs to C. So we have all X belonging to A. For all X belonging to A, what we have, X belongs to C. We started from this and ended here. That means A is subset of C. So this is true. Coming to fourth. According to fourth, if A is not subset of B and B is not subset of C, then A is not subset of C. Why I am doing this miscellaneous exercise problems? Because in CET also you will have difficult questions like this. So you must practice difficult questions. I will say this is false. Why it's false? Let us think A is 1 comma 2. Now they said A is not subset of B. That means B I have to take in such a way that I should not have 1 and 2. So I'll not take 1 and 2. Apart from that, I will take anything else. Then because they said B is not subset of C, in C, I will not take 0, 6, 8. Apart from 0, 6, 8, I mean all the three, 0, 6, 8, I should not take. If I want, I can take 0, 1, 2. I can take 6. But I will not take 8. Then B will not be subset of C. But then you can see A is subset of C. Because in A you have 1, 2. In C also 1, 2 is there. So what they gave is false. Next, fifth one. If X belongs to A and A is not subset of B, then X belongs to B. I say this is false. For example, A I will take 3, 5, 7. Now A is not subset of B. So when I take B, I should not take all 3, 5, 7. If I want, I will take 3, but 5, 7 I will not take. This is how I have taken. So suppose 5 is there in A, but 5 is not there in B. That means what they gave is false. Okay, now we will take sixth one. Sixth one says if A is subset of B and X does not belong to B, then X does not belong to A. This sixth one, I will say it is true. How it is true? It is said that A is subset of B. That means if X belongs to A, then X has to belong to B. But they are saying X does not belong to B. They are saying X does not belong to B. So what they have given is true if X does not belong to A. That means if X does not belong to A, then X does not belong to B. That only can happen. So this I can take as true. A is subset of B. I agree. If X belongs to A, then X has to belong to B. If X does not belong to A, then X does not belong to B. That is what we are proving here to be true. Okay, let's go to next question. We have completed second question. Yes. So we will go to third question. In third question, A union B is equal to A union C, and A intersection B is equal to A intersection C. Show that B is equal to C. So we are given A union B is equal to A union C. And we are given A intersection B equal to A intersection C. Let us take X belongs to B. So that implies X belongs to A union B. Because A union B and A union C are same, this implies X belongs to A union C. Isn't it? That means X belongs to A or X belongs to C. Union means or. But we have seen that X belongs to B. Here we got X belongs to A also. That means X belongs to A intersection B. Similarly, we have taken X belongs to B, X belongs to A. Isn't it? Okay. So, because X belongs to A intersection B, because A intersection B is same as A intersection C, that implies X belongs to A intersection C also. Isn't it? So we can say X belongs to A and X belongs to C. That we can see. But what we got here, we got X belongs to B. And here we are getting X belongs to C. That means for all X belongs to B, X belongs to C. Or the set B will be equal to set C. This is how you have to prove. Coming to fourth question. Show that the four conditions are equivalent. What are the four conditions? A is subset of B. A minus B is phi. A union B is B. A intersection B is A. So, what they are saying, 1 is equivalent to 2, 2 is equivalent to 3, 3 is equivalent to 4. That means all are same. So first we will prove 1 is equivalent to 2. A is subset of B, we will take. And we will take A minus B equal to 5. Now, if A minus B is equal to 5, what do you mean? A minus B equal to 5. From A, if you remove B, nothing is there. I will tell you in sets. Suppose B is 1, 2, 3 and A is 1, 2. Suppose from A you remove B 1 and 2. Nothing is there, isn't it? A minus B, nothing. That means we can say these two are same. These two are equivalent. Saying it is equivalent. Isn't it? So we have proved that. Similarly, we will prove 1 is equivalent to 3. How we will prove 1 is equivalent to 3? We will take A as subset of B and we will take A union B is B. The same example we will take, whatever we have taken here. So A union B, when you take, you will have 1, 2, 3. That is nothing but B. So these two are equivalent again. What did I take? A is subset of B. Same example I have taken. Okay, next I will show that 1 is equivalent to 4. That means A is subset of B. A intersection B is A. So I'm taking the same example. 1, 2 is subset of 1, 2, 3. So if you take A intersection B, common is 1, 2, which is nothing but A. So I have proved these two are equivalent. That means 1 is equivalent to 2, 3, and 4. So I can establish that 1 is equivalent to 2, 2 is equivalent to 3, and 3 is equivalent to 4. There is another method also, difficult method. Let us do with this simple method. Fifth question is, show that if A is subset of B, then C minus B is subset of C minus A. So let us take, we will start with this. Let X belongs to C minus B. That means what? X belongs to C, but X does not belong to B. But we are given that A is subset of B. We know A is subset of B. Because we have X does not belong to B, that means X does not belong to A. So it means that what we started, X belongs to C, X does not belong to A. X belongs to C and X does not belong to A. That means X belongs to C minus A. So we ended up here. We started here. Actually, this is the starting point. I will highlight. We started with this and we ended with this. That means for all X belonging to C minus B, X belongs to C minus A also. That means C minus B is subset of C minus A. Let's go to question number 6. If power set of A is equal to power set of B, show that A is equal to B. Now, first of all, we are given power set of A is equal to power set of B. That means if X is an element of A, since P of A is the power set of A, it has all the subsets of A. So, because P of A has all subsets of A, A is also an element of P of A. If A is an element of P of A, because P of A is equal to P of B, A will be element of P of B also. So, what we are trying to see here is, if C is an element of P of B, or rather, if we start like this, if C is element of set B, because B is element of P of B, I can write C also will be element of P of B. Right? So now if X belongs to C, from this, if X belongs to C, then X belongs to B also. So I can say C is subset of B. Isn't it? Now, X belongs to B also. X belongs to B. X belongs to A. X belongs to B. That means A is subset of B. Similarly, we can have B as subset of A also. Like this also I can write. So finally, if A is subset of B and B is subset of A, I can say A is equal to B. That is what I have to prove. That is the proof which is needed. Quickly, we will complete one more question. Is power set of A union power set of B equal to power set of A union B? Justify your answer. I will take A having 0, 1, B having 1, 2, and A union B will have 0, 1, 2. Now, power set of A will have empty set 0, 1, and 0, 1. Power set of B will have empty set 1, 2, and 1, 2 all. Now, power set of A union B will have empty set 0, 1, 2, 0, 1, 0, 2, 1, 2, and 0, 1, 2. Now you can see power set of A union power set of B will be empty set 0, 1, 0, 1, then 2, then 1, 2. These all are there for power set of A union power set of B. That means we can see power set of A union power set of B is not same as power set of A union B. So the given statement is false, not true. We have 10 more questions. So come prepared for the next class. We will complete these 10 questions and then we will go to CET, where we will be studying some more questions on the sets. If you are good with all these questions, then only we can understand CET questions. With this, I will end the class.